Hello everyone, welcome to today's DTT event. I will start in a few seconds if you just kindly wait. I will share my screen again. Kubra, can you please put the screen sharing on the screen? Yeah, thank you. So I think we can start. Good morning or good afternoon, everyone, wherever you are. It may vary. So today we are on the another DTT event, which is about containerization and orchestration in Huawei Cloud. We will specifically use the Huawei Cloud Container Engine, of course, CCE. So if you want to get a certificate on this event, you can register from the QR code which is depicted in the screen. You can do it during the presentation, I suppose. I think it's not closed yet, but let me start my presentation. But firstly, let me briefly introduce myself. Ertuğrul Başar, as you may see on the screen, I graduated in September 2022, and since then, excluding my internships during the university, I have started my professional career at Huawei, and I have been working as a cloud engineer for approximately 1.5 years here. Yeah. For the contents, so in this presentation, we will begin by discussing Docker and Kubernetes. Following that, we will delve into Huawei Cloud's Kubernetes solution CCE. And lastly, I will provide a hands-on demonstration. So let's start with Docker. But before we start with Docker, let me give you a brief information about containers. A container is a standardized unit that packages an application and its dependencies. It's like a self-contained virtual environment that ensures the application runs consistently across different environments. You can think of it as a portable box that contains everything the application needs to function. And Docker is a popular platform that simplifies the creation, deployment, and management of containers. It provides a set of tools and services that makes it easier to build, ship, and run applications in those containers. It also is a powerful tool that has revolutionized the way software is developed, deployed, and scaled. It provides a simple and efficient way to package and distribute applications as containers easily. Also, we need to mention Docker images. They are like blueprints or templates for containers. They contain the application code, dependencies, and configuration settings required to run the application. And when you create a Docker image, you are essentially defining the environment in which your application will execute. And in summary, let's say Docker images provide the instructions for building containers, and the containers are the actual running instances of the application. We can overview the Docker like this. Let's continue with Kubernetes. Kubernetes is an open source platform for automating the deployment, scaling, and management of these containerized applications. It's often referred to as a container orchestration system, This is the definition of it, probably container orchestration system. It was originally developed by Google, but now it is maintained by the CNCF, which is Cloud Native Computing Foundation. It is designed to automate the deployment, scaling, and management of containerized applications across various environments, including public clouds, private clouds, and on-premises data centers. Yeah, this is pretty much the overview of the Kubernetes, but we need to, look at the architecture of it. A Kubernetes cluster consists of master nodes and worker nodes. These master nodes are called control plane as well, by the way, and it acts as the brain of the Kubernetes cluster, makes the decisions and coordinates the activities of the worker nodes to ensure that the applications are running smoothly and efficiently. So if there's any problem, master node just acts and solves it. And applications are developed in these worker nodes. We can specify the nodes for deployment. And for CCE, Huawei's Kubernetes solution, master nodes are hosted by CCE. You just need to create worker nodes, which we will do it in just time. By the way, we can look at some of the main Kubernetes components as well. One of them is pod. Sorry, one of them is pod. It is the smallest unit of deployment in Kubernetes. It represents a group of containers that are scheduled together and share resources. A pod can contain one or more containers as well as shared volumes and network interfaces. A second component we are going to talk about is service. It's a logical grouping of pods that provides a stable network endpoints for applications. It abstracts the details of how pods are distributed across the cluster, making it easier to manage and scale applications. Other one we can talk about is stateful set. It's a declarative object that manages a set of pods with a stable network identity and storage persistence. It is typically used for applications that require persistent storage or a specific order of pods. We will also create stateful set in our hands-on deployment. And deployment, it's a declarative object that manages a set of pods and ensures that a desired number of replicas are running. Config map, it's a way to manage configuration data for applications. And lastly, secrets. Secret is a way to store sensitive information such as passwords or API keys. You can configure it on your cluster, on-premises cluster, or in your cloud environment as well. Now it's time for Huawei Cloud's Kubernetes solution CCE. This Cloud Container Engine is a cloud-based container orchestration platform that provides a managed Kubernetes service. It simplifies the deployment, management, and scaling of containerized applications on the Huawei Cloud Console. It offers fully managed Kubernetes environment with features like easy scalability, high availability, robust security, and seamless integration with other Huawei cloud services, which we will use in a minute. This makes it a convenient and efficient solution for deploying and managing containerized applications on the Huawei Cloud platform. So I wanted to simplify the theoretical part so we can spend time on the hands-on. So now let's go to the Cloud Console and make a simple exercise. I'll just stop sharing and share my screen again in a few seconds. Wait a second, please. So I've got some of the comments that I will use in the exercise, but I want to prepare them before sharing my screen. Also, I will connect to the ECS cloud, ECS instance with my with SSH. So, okay, I think I can share my screen now. Yes, I am sharing it. Kibra, can you please put my sharing into the stream? Yeah, thank you. So let's start with buying a Kubernetes cluster. It takes some time, like 5 to 10 minutes. That's why I will first uh, what's the problem? Well, maybe you can write it down to the chat box. Oh, yeah. Is this okay? Okay, maybe I can check it as well. Yeah. Let me get into the YouTube and check the stream. Okay, I think it looks fine, but okay, I think it looks fine, but I can zoom one more so you can look, you can see better. Let me see. Yeah, I think now it's readable. Yeah. So, like I said, we will buy a CC cluster first because it takes time. Then I will go to the ECS page and buy an ECS instance. So I will create standard CC cluster and choose pay-per-use because it's better for now. Let's call it CC DTT. Let's price project will make me, I don't know. Okay. So cluster scale will be 50 because I don't need to, you know, I won't even buy nodes more than 4. So 50 is enough. For the master nodes, we can get a single. When you get a single node, I think you cannot choose 1,000 yet. You need to choose 3 master nodes if you want more than 1,000 nodes. So okay, VPC. I created a VPC earlier, so I can just choose it. Containers, yeah, okay, auto select. Yeah. You can also choose and install some of the add-ons here. I won't uh, choose anything for this exercise. So okay, after I check this checkbox, click on this checkbox, I can submit it. Okay, task is submitted, but like I said, it takes some time. So during this time, I'll go back to the Cloud Console and buy an ECS instance. Okay, let's click on buy. Again, let's choose pay-per-use as the billing mode. Yeah. I don't need to get a very strong machine, so 2 to 4 is enough. As an image, I will use CentOS. You can use the same VPC. Secure the group can be default. And for the EIP, we can get 400. Let me check the security group rules because of I will open an SSH. 22 should be allowed. ECS name, make it ECS DTT. Doesn't matter. Or maybe we can do this. 300 megabits per second. Login mode. Let's create a password. Enterprise projects. Let's see. Is there anything here? Okay. We also need to agree to this. It's still on the creating status. Okay, let's go back to the ECS list. After it's on running status, I will open an SSH code. Okay, it's on running status. I'm just waiting for next load. So after that, I will get public IP. Okay, so I got the public IP. Let me just copy it and wait a sec, please. So I will just create a session here. Okay, I think we can. Yes, it asks us the password. Okay, now we're the first thing we need to do here is install the Docker, but before that, let me just update the machine. Okay, it's completed. After we update the machine, let me just reload. We can install Docker. I will use these commands to install the Docker. By the way, let me see it if it's running or not. So it's creating status again. Okay, let me look at the Docker's, sorry, status, if it's running or not. No, I guess it's inactive, but yeah, wait a sec, please. Let me copy these comments. So, okay, now it's active and running. That means that we can now pull the images that we are going to use in this exercise. So I will pull two images. One of them is MySQL and the other one is WordPress. Let's pull those images. Now I think you may see it. I'm zoomed it in. Alright, the second image is this. Okay, so we pulled two images that we are going to run on our Kubernetes cluster, but before we can run it, we need to create an organization in SWR, which is our platform, repository platform for images. But before we create an organization, we just need to create the nodes on our CCE cluster. This will be the worker nodes. Like I said, let me buy for you don't need this much fast storage, so I'm lowering them. So this will also take a few minutes. That's why while they are being created on in our cluster, I will now go to SWR and create an organization which we can push our images. So here we can click on there and let me say it like organization BTT. In the organization list, we can see that our organization is created, and after we push images to this organization, we can look at them here. So let's upload the images to organization. So first thing we need to do here, generate a login command so we can log in from my ECS. As you can see, we have logged in. By the way, I need Docker image ls. I can show you that the images are successfully pulled from the Docker registry, Docker IO, or Docker app, whatever you call it. So next thing we are going to do, of course, upload the image. So we will click on upload through client. We already logged into the cluster, or sorry, SWR. So we don't need to do these steps, but we need to take our image, both of our images, so we can push it to the Huawei Cloud SWR. So I will use this command. Wait a second, I am preparing it. So I will use this tag command. So it will take this image to this one. So, but the problem is that I'm not in the tier west region. That's why I need to change it from here. It changes on every region. So let me change it in my local, then I will show it to you. I think this time it's okay. If it's not, you'll probably get a warning, but no problem, we can fix it. Let me just check the organization name again. Okay, it's org-dtt. Okay, so I tagged the two images, and you can see that those images are here and ready to be pushed. Let's push them, but this time we will use Docker push instead of Docker tag. So let me copy the command that I have here. Okay, so it pushes the images to the SWR. After it pushes, oh sorry, I accidentally pushed one of them to the wrong region. Because of that, we will see only the WordPress. I need to push the MySQL again. Let's do it. Oh, what is it called? Oh, sorry, I forgot to change the organization name. That's why it happens. Okay, this time it should push, yeah. No problem this time. Please share the necessary comment with us. Thank you. Actually, you can look at them like this. Wait a second, please. If you just Google it like this, you will get the required comments. You can Google it one by one. I don't think it's possible to share it with you right now. So, okay, let's continue. Let me refresh it. Okay, notes are ready, by the way. So you can use these worker nodes to deploy our application. But before we do that, I want to show you guys another thing because with Kubernetes, you have two options, or with CCE, of course, you have two options. First one is using the command line from here after connecting to the Kubernetes cluster, or using the Cloud Console, using the graphical user interface to create workloads, etc. So for right now, I will just show you how to connect to the Kubernetes cluster, but after that, I won't do anything from the command line. I will do my operations on the Cloud Console. So the first thing we need to do actually is configure the kubectl in our machine. So let me use these comments so we can install the kubectl to our machine. So okay, I think let me, we didn't connect the cluster, but maybe yes, because of we didn't connect it, there's an error. But I want to see if it's working or not. Okay, we can clear the screen and let's go to the home. Okay, we don't have the kubeconfig file here, so we cannot cube file actually. But actually, it's cube folder. That's why we won't be able to connect. But let me create it. So we can create a file like this, and after I refresh it, I still cannot see it. Wait a second, please. Oh, that's because the home is actually root, probably. Let me go there like this. Yes, home is actually, as you can see, the root file. That's why I couldn't do it. But we can go to this cube folder from here. Yes, and we need to create a config file from here to here as well. Or we can do it with the command. Whatever. Can use this slash. Okay, right now we can see it. We should actually download the YAML file, kubectl YAML file here, and after that we need to start the kubectl. Let me download this file. Okay, we can copy it here. As you can see, the file is here, but sorry, actually, I did a mistake. This file should have been named config. It's not the folder's name. It should have been the file's name. So I will go here to downloads. I will name it this config. Okay, not a problem. After that, I will copy it here. Yes, you can see it. And after that, I think we can use this file. So, yes, as you can see, we have logged in to our CC cluster. Here we can create some workloads, but before we do that, we need to bind an EIP to the CC cluster, but I won't do it. I will just use the images that we push to the SWR and create MySQL and WordPress workloads. So in order to do that, I will go to the workloads page, and first I want to create a stateful set, which will be MySQL. We can do one pod, doesn't really matter. Here I will use MySQL that we have pushed here. Okay. We can also create a headless service. So port will be 3306, and I will also create a cluster IP here, so it will help this database workload and WordPress workload to communicate. By the way, you can also, you know, limit the resources from here. Also, you can configure some of the settings as well, but here I will add four variables, which are one of them will be MySQL root password, one of them will be database name, one of them will be MySQL user, and last of them will be MySQL password. I also have the values here, so let me just copy them. I can use the same password here again. So okay, I think we did all of the things we need to do, and we can create the workload now. Let's view the workload list. And because of that, it's on SWR. It goes into the status running quickly. Here we can look at it. This is our pod. We can upgrade it from here. We can change the limits, resource limits, or environment variables, etc. We can do it like this. Also, we can create workloads from the YAML file. Yeah, so we can use YAML file. Let me look at my local. Maybe I have a YAML file that we can use, but like I said, because of we did not bind any EIP to the cluster, it won't be able to pull the image. But still, I would want you to see, how does it works. I will just okay. So I can use this file and then click on OK. After I click on OK, because of it has Nginx already in open source images. Sorry, on the deployments, by the way. Probably, or pods, yeah. Pods. Yeah. It was named request name, by the way. Because of it has Nginx already have in the open source images. Let me show you. It's here. Because of it has Nginx here, it didn't need to download the image, and that's why we could access to the Nginx image file. Yeah, but if your image is on another site, you may, think to bind an EIP to the CC cluster, so you can have an access to the image. Yeah, let's delete this pod. We don't need it. We can, we, 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 can, we Now we can create another workload. This time it will be our WordPress. Yes, let's choose it for the service. And I will get onto this later. Okay. We are using default secrets, by the way. Maybe you can remember that I mentioned it on the main Kubernetes components. Okay, so let's add the environment variables again. Let me just copy them. So some of them are the same with the MySQL, but there's one thing we need to copy from the Cloud Console. Oops. So this host is the cluster IP that we have created when we created the MySQL stateful set. So here, on the addresses side, um, okay, let me find it. Yeah, okay. This is the thing that we are looking for, but we can also use this as well. But this is the domain name internally, so we can use it. But like I said, you can use this IP address as well. Yeah. So, okay, I think there's nothing else I need to do here. So let me just create it. Okay, it's on running status. So we have created the workload, but we cannot have an access to it. That's why we need to go to the access mode. There are a few options here. One of them is cluster IP. That's what we used with the MySQL. One of them is node port. One of them is load balancer, and one of them is DNet. We can use load balancer here, I guess, or maybe node port, but this time I will use load balancer here. So for the we can create a new load balancer here. Let's say ELB Let's get an EIP. Okay, we will connect to this workload from AD. As far as I remember, we can try it after the load balancer. Turns on. Okay, so the load balancer is turned on, and we can okay, we can use this public IP. So after I enter it, I want to see that WordPress page. Okay, as you can see, we can see it. So we actually did the exercise we are going to do. Just let me create this WordPress page. Okay, we can log in. Again. Because of probably because of I gave a little bit of resources to this deployment. Let's upgrade it. I'm getting some slow. Okay, so request. Uh, oh, okay, this time it should be better. As you can see the YAML file by the way. You can just copy it and change it. After that, you can upgrade it with this file. So we can see the changes we have done here. We gave lots of more CPU as a request and memory. So I will just submit it. I think now it will be faster. Okay, okay. As you can see, we can connect to the WordPress page. Here we can do some of the configurations you want to do. But I want to show you that this time we come here. We will just see the WordPress main page. Maybe this is because of my connection, by the way, not because of that. I gave limited resources to the cluster. Sorry, deployment. Okay, yeah, as you can see, uh, we can create, we can connect to the WordPress. So actually, we have finished our simple demonstration, but I want to show you guys some other things here. One of them is how to create a secret. So you can come here to secrets because of I use my own default secret. I didn't need it, but here you can new secrets. You can create another secret. You can use some other things here. This time I will choose Kubernetes IO, Docker config JSON. Here I will use the command that I used in the login into the Docker repository side. Yeah, this is the image repository address. This is my username, and this will be my password. After I click on OK, I can use this new secret in my workloads. Let me just show it to you. As you can see, we can use the new secret here. If you want to, you know, use your secrets, you can create it like this. Okay, the other thing I want to show you guys is add-ons, and it's about the where is it? It's about the auto scaling. Let me show you from the workload side first, and after that I will go back to the add-ons page and show you guys how to install add-ons, etc. So if I want auto scaling, I can come here, and but as you can see, we cannot create AS policy. When I want to create a AS policy, we need to. It says that we need to install these add-ons. So you can click on install now here, or we can go to the add-ons page and install it here. Where was it? Maybe I can schedule. Can this here to scaler, not this one. Yes, this one. I guess advanced HPA, right? Yes, we can install this here. Let's click on install, yeah. And it's on installing status. Let's refresh here. Let me refresh it. Yeah, as you can see, it's installed. So, and I click on this. This time it also wants me to install this one. Okay, install this one as well. I thought I installed it, but okay. So task is delivered. Oh, okay. Doesn't really matter. But this time I will go to the policies and click on HPA policies. Pod range is 1 to 10. It doesn't really matter. The one thing that really matters is here, the system policy. So I will choose CPU usage or memory usage or auto scaling policy. We can use CPU usage. Desired value maybe 40%. Yeah, we can use this. And after that, maybe I can. By the way, we can also customize the scaling behavior, but I will keep it on default here. Associating workload will be WordPress. Okay, let me create it. It's initializing. Okay, as you can see, we can see that the auto scaling is started. After I refresh this page, I think I will see it. Yeah, as you can see, we can see that the policy is in the WordPress workload. So we can it can scale the application based on the CPU usage. Yeah. So we can also change some of the things like scheduling policy or APM settings, but we don't need to do it right now. What we can do here is look at the custom resources side. Here you can create some resources from YAML files, custom resources. I wanted to also mention it as well. And on the overview page, we can maybe look at some of the other things we can look. One of them would be these graphics. As you can see, our CPU allocation is 47%, but usage is like 2%. And also for the memory, we are on the safe side. We can do it like this. On the right pane, we can look some of the things we did here. Like we can add some container CIDR block. We can edit the security group. Let's look at the security group here. Let's look at the inbound roles. So these roles are, these ports are open in this cluster. I want to show you this as well. And for the connection info, this is the internet URL of the cluster. We probably used it on the config file. Let me look at it. It's config. Yeah, as you can see, our server IP is here, and because of its internal cluster, it can connect because they are on the under they are under in the same VPC and subnet. We can bind an EIP from here. We can do it from here. We can configure the kubectl as a YAML or JSON. I showed you this earlier when we connected to the cluster. Also, you can look at some more information here that are really not important actually. Yeah, actually, this was my, this was all from me. So unless you have a specific question, we can finish the session here. Yeah. But before we finish it, I think we should do the best, and we should clear the resources that we bought. So first thing I will do here is delete the cluster. I will also delete the cloud storage network resources and log streams, so they won't be built after I delete the cluster. After you see that it's deleting, we can go to the ECS page and delete the ECS as well. But by the way, because of CC worker nodes are from ECS instances, you can see that they are here on the deleting status. Okay, we created this ECS DTT. Okay, they are deleted. That's why they all went off. We created this instance, so I will delete this as well. I want to delete the EIP and data disks as well. Let's click on auto enter. Okay, yeah. Okay, after deleting the ECS as well, I don't think that there's something that I should mention in this demonstration. So I think we can close the session now, but before we close it, I want to look at the CCE console again and see that the CC cluster is deleting it. It takes a few minutes, so you may need to check it again. After it's deleted, it won't be built. It won't be built. So I wanted to delete it after I finished my demonstration. I will recommend you to do the same, because if you forget to delete the resources that you don't use, you may face with unexpected bills. So I recommend you to delete the resources that you don't use, even pay-per-views, or even you think it's cheap. Okay, so it will get deleted, but I think we can finish the session here. Uh, I think you guys don't have any questions, so I think we can close the session now. Yeah.